In lesson 2.2, we're going to learn about exponents and powers of 10. You're going to need your whiteboard marker, an eraser, and your math journal. So once you have those items, go ahead and start the video. If not, go ahead and pause it and get yourself ready. On your whiteboard, you are going to write numbers based on some clues given here. So for number 1, you're going to write a number in which 8 is worth 800. So that's number 1. Number 2, you're going to write a number in which 8 is worth 1/10 as much. 1/10 as much. So let's do the first one together. As long as it has an 8 in the hundreds place, you can put any number here. 824, 872, 814, 809. As long as there's an 8 in the hundreds. Now, let's go ahead and take 824. If I'm going to find a number that has 8 that is worth 1/10 as much, so think of it as dividing by 10, my 8 now is not going to be worth 100, but is going to be worth 10. So what is a number that has an 8 not in the hundreds place anymore, but in the tens place? I could say 84. Okay, so I'm going to erase that, and I'm just going to change, since I did that one with you, I'm going to change it a little bit on you. Now I want you to try this one on yourself. Write a number that has a 5, or is worth 500. Write a number in which the 5 is worth 500, and then write a number in which the 5 is worth 1/10 as much as that number. So go ahead, pause the video, and write this on your whiteboard. So if I'm writing a number with a 5 that's worth 500, I could say 576, 522, 590. So I'm going to go ahead and stick with 576. As long as yours has a 5 in the hundreds place, you are good to go. Now, if I write a number in which that 5 is worth 1/10 as much, so I'm going to divide that number by 10. In other words, the 5 is no longer going to be in the hundreds place. It's moving 1 to the right. 56 would be 1/10 as much. All right, go ahead and wipe off your whiteboards. I'm going to do one more problem like that. You're going to write a number in which the 7 is worth 7,000, and then write a number in which the 7 is worth 100 times as much. 100 times. So think about that number is going to get 100 times larger. So I just stuck a little chart in there. So remember, if we're talking a 7, imagine this is a 7, okay? And we want it 100 times. 10. Where is that 7 going to have to be? Okay, so just think about that. All right, so I'm going to write a number with a 7 in the thousands place. I'm going to say 7,241. As long as you have a 7 in the thousands place, you have that part correct. Now, if I'm going to make a number that is 100 times greater, think about this, 7,000, and I need 100 times greater. It would have to be 700, right? 700,000, because the 7 was here, right? So just imagine it was right here in this number. This would be 10 times greater. This would be 100 times greater if originally from that thousands place. Each time you move over 1 to the left, 1 place value to the left equals 10 times greater. 2 places to the left would be 100 times greater. 3 places to the left would be what? 1,000 times greater. So in this case, I need to just have the 7 in the hundred thousands, and then I can put any number after it that I would like. All right, let's go ahead and look at some vocabulary that you're going to be encountering during this unit. We use exponents when we're writing really large numbers. The first one is exponent. That's this little smaller raised number next to the 10. It's shifted up and to the right. Base is the number 10 here. We are going to only deal with base 10 in this lesson. We also call these powers of 10. And lastly, exponential notation, which you see is that whole thing right there. Let's go ahead and open our journal to page 41. Page 41. Powers of 10 and exponential notation. I am going to read each of the columns and you'll fill it in as I do. So you can see an example there. We read this as 10 to the 6th power. As an equation, as a product of 10, we would write 10 times 10 times 10 times 10 times 10 times 10. In standard notation, that would equal 1 million. All right, let's go ahead and fill out 10 to the 5th power. Notice my 5 is a little bit smaller and raised up. So we would call that 10 to the 5th power. That means taking 10 times 10. Remember that little dot also means to multiply. Times 10 times 10 times 10. In standard notation, that would have 1 0, the number 1 followed by 5 zeros. 1, 2, 3, 4, 5. I start from right to left and count every third digit. I put in a comma, 1, 2, 3, comma. So in standard notation, 10 to the 5th power would be 100,000. All right, let's write 10 to the 8th power. That means 10 times 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7. One more, times 10. 10 to the 8th power is taking 10 times itself 8 times. Then 10 times 1, or 10 to the 8th power would be a 1 with how many zeros behind it? 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go ahead and count from right to left. Every third digit, I'll put in a comma. 1, 2, 3, comma. 1, 2, 3. 100 million. And lastly, let's do 10 to the 3rd power, or 10 cubed. That means 10 times 10 times 10, which in standard notation would be 1 followed by 3 zeros, which would equal 1,000. Now if we look at completing the number sentences, it says that 3 times 10 to the 2nd power is the same thing as 3 times, there's my 2 zeros, 3 times 100, which would equal 3 times 1 is 3, with 2 zeros behind. Number 2, 7 times 10 to the 9th power is the same thing as 7 times, and then let's look at this. How many zeros are going to be after the 1? 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then put in your commas. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. That number is 1 billion. That's a pretty big number. So then we take 7 times 1, which is 7, and then we count up all the zeros. 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those commas help us read, just like if we were driving, we have road signs. Our commas are road signs to help us read large numbers. Number 3. 3 times 10 to the 4th power. That is taking 3 times 1 with how many zeros behind it? 1, 2, 3, 4. So 3 times 10 to the 4th power is really 3 times 10,000. 3 times 1 is 3 with 1, 2, 3, 4 zeros. 1, 2, 3, 4. 30,000. Number 4, 25 times 10 to the 3rd power is the same thing as taking 25 times 1 with how many zeros behind it? 3. Now all we have to do is take 25 times 1. Any number times 1 is itself 25 with 1, 2, 3 zeros behind it. Number 5 says that 93 times something gives me 93 million. I'm going to count how many zeros. 1, 2, 3, 4, 5, 6. 6 zeros. So that would be saying 93 times 10 to the, and how many zeros again? 6th power, which is the same thing as taking 93 times, put in that 1, followed by how many zeros? 1, 2, 3, 4, 5, 6. 93 times 1 million. Let's move down that page. Number 3 we've already done, so we're going to skip down all the way to number 6. Mine was just on the previous page. The numbers in problems 1 through 5 are the answers to the following questions. Fill in the blank with your best guess. Write it in exponential notation. So, I've inserted the answers from numbers 1 through 5. You can see it, but it is here as well. So, number 6A, the distance from the sun to the earth is about how many miles, do you think? Well, it's 93 million. It's this one right here. So it is about 93 million. Here's another way to write it. That is in what we call exponential notation, a shorter way of writing 93 million. Okay, so this one's done. 6B, the Statue of Liberty is about blank feet tall. I don't think it's 7 billion feet tall. I would say our best estimate would be 300. Another way to write that, if you wanted to, you could write 3 times 10 to the 2nd power, but that's not a huge number. Okay, in 2014, the population of Earth was about how many people? What's your best guess? There we go. It was about 7 billion people. It's a lot of zeros to write, so I can also write 7 times 10 to the 9th power. Means the same thing. All right, we're down to 2. D, if you walked around Earth's equators, you would walk about blank miles. How many miles? Is this one 25,000? You would walk 25 times 10 to the 3rd power, or what we would call 25,000 miles. And lastly, Mount Everest, the highest mountain on Earth, is about 30,000 feet high. On our next journal page, on page 42, you are going to look at numbers in expanded form, that they can be written as addition expressions showing the value of each digit. So we're going to do some of these together. We won't do many of them, but it says number 1A, write 6,125 in expanded form as an addition expression. So I'm going to take the value of each digit. So go ahead and write 6,000 plus the value of the 1, 100, plus the value of the 2, 20, and the value of the ones. 1B, write 6,125 in expanded form as the sum of multiplication expressions involving powers of 10. So 6 times 1,000, and then the sum, so I'm going to add together this multiplication, 1, which is in the hundreds place, plus the value of the 2, which is a 2 in the tens place, and lastly the 5, which is in the ones place. And the last one we're going to do today is C. Write that same number in expanded form as the sum of multiplication expressions using exponents to show powers of 10. So let's just refer back up to this one. 6 times, instead of writing 1,000, I'm going to write 10 to the 1, 2, 3 zeros plus 1 times 10 to the 1, 2 to the second power plus 2 times 10 to the first power plus, and we write the ones place as 5 times 10 to the 0 power. All right, that's all we're going to do for today. It was a rather long lesson. Thanks for hanging with me.